So in today's class, we are going to talk about clippers. Fine. Can anybody tell me what is a clipper in the screen? We have got a definition or a clippers. In fact, in English, clipper means cut. So what we mean by clipper, that if you have got a signal, we in the input and we want to keep some part and remove baki, then this will be an example of clipper. For example, see this circuit. Can you see this circuit on the screen? In this circuit, this is the input we are applying on the left side, and the output will be there on the right side. So this is an clipper circuit. Now, this one particularly is called as series clipper. When you say series, you know series and parallel definitions in resistances. When your diode will be here, then this circuit will be called as series. And when your diode will be here, then this will be called as parallel. Hope it's clear. Okay? When your diode is here, the way it is right now in the screen, it will be called as series clipper. But if it will be in the place of a resistor R, then it will be called as parallel clipper. I will show you a circuit. Can you see the circuit? Yeah, can you see the diode on the image on the screen? This is the example of parallel clipper. When your diode is in parallel to the output, this circuit is called as parallel clipper. Now going back to these examples, your diode is in series with the input. Your input is here, and in the series with the input you have got your diode. Then this kind of circuits are called as series clippers. Fine. So you can get a question in the exam. Draw the series clipper circuit, or maybe you will get an input like the way we have here, and you will get the circuit and you have to find out the output. Fine. So this is very simple, but anyway, we'll discuss one by one. Now let us discuss how we are going to get the output, the one we have here. Fine. We'll discuss this just now. So if you see, your signal is having two halves, positive half and negative half. So to make it clear, we will start one by one. Let us talk about the positive half only. When we say positive half, what do we mean? This is plus and this is minus. And we know how a diode behaves. Diode, this is called P side and this is called N side. For the input we are discussing right now, this P is positive and thus N is negative. It means our diode is what? Forward or reverse? It will be, of course, forward, because we know the condition for forward bias. P is positive, N is negative. It means our diode is forward bias. And if our diode is forward bias, then barrier will be almost zero, or current flow in a very easy way. Natija, your signal you apply on the input will go, and the same signal will be there in the output. That is why we are getting output like this. Hope it's clear. Okay. Now let's talk about negative half. What difference you see if you will think about negative half? The difference will be in the signal we are going to apply. What will be the difference? This is minus and this is plus. Now what is the difference in the circuit? Your diode is getting opposite. What do you mean by opposite? P side is getting negative terminal and N side is getting positive. It means your diode is reverse biased. And you know how a diode behaves when it is reverse biased. The potential area around the junction is big, and thus current is not there or very small in microamperes. So we can say that it is like a barrier which stops your signal in the input to go to the right side towards the output. So you can say that your output is not there or output is 0. So this is how a diode behaves. So whether your signal is square wave or triangular wave, your signals will be in the output, only positive signal will be there and negative will be gaib. Same here, it is present positive high and negative. In fact, it is the same circuit of half-wave rectifier. I hope you remember half-wave rectifier. In half-wave rectifier also, only one half is present in the output and another half is not there. So this is what is a diode clipper or series clipper. Hope it is clear. Any questions from anybody? If you have any questions, you can message to me so that I can immediately share in the group what is the question and I can answer, but you have to be fast. So this is about series clippers. We have got another clipper. Another example, in fact, you can get questions in the exam which may not be as simple as your previous circuit, but a circuit like this. Again, the circuit is very simple, and this is also series because of the location of the diode. It is in series with the input signal, but it is not like the previous one. Why? Because of this battery that you can see on your screen. You can see the difference, right, in comparison to the previous circuit. So let us talk about this bias clipper, what we are going to get in the output. Let us talk about that. As you can see that this circuit is having input signal and a battery in the circuit. So let us talk about this in detail. Now your signal has got your diode is going to get two sources or two isharat or two batteries. One is this one and one is this. But if let's we'll start step by step, or we will start with positive half. In case of positive half, this terminal is positive and this terminal is negative. During the same time, let us assume this is Vi, but especially about positive half. Also, we have got a battery. This terminal is big, we say it is positive, and the symbol for negative, a small one, is negative. Now, if you notice, both of these voltages are going to make your diode forward bias. So things is very clear. During Kamil, during whole of the positive half, your diode is forward bias. So it is, we can say it is like short, or it is like an easy way for the current to move. Now, how much is the output? We can calculate by KVL. You can use it, this is a loop, or we say daira. So in this loop, how much is the output? We can calculate by using KVL. Let us start from this point, and we are going in the clockwise direction. So if you go in the clockwise direction starting from this point, then we say at first minus, so we say minus Vi, then again this battery minus 5, this diode is short, so 0, so no need of write. Again these two are parallel, our resistor and output are parallel, so we know very well that parallel have got the same voltage. So what is the voltage here? As we are going clockwise, at first we will get positive, so we will write plus VO. So this is all the voltages we have got in the loop, and we know KVL is the addition of all the voltages in the loop is 0. Now why we have write this question? We want to solve the value of V output. So now we will simplify and we will write VO equals to, we will take all the other values on the right side. So it will be Vi plus 5. VO will be Vi plus 5. So it is very simple. Now let us talk about, your signal has got different values. It starts from 0, going up, reaching 20, then going down again. So for example, in this point, or when the voltage input is 0, your output will be 0 plus 5. it is 5. See the voltage. This is the input and this is output. When input is 0, output is 5. When input is 1, output is 6. When input is 20, output will be 20 plus 5, that is 25. Then it will go on decreasing. When it is 10, it will be 15. When it is 0, it will be 0 plus 5. So this is how we will solve for positive half. Fine. Okay. Even if let us talk about the case when our just a minute. Let us talk about the when your input is negative, like in less than 5, maybe -3, -2, -3. In this kind of cases, it will be minus, it will be plus. Your input voltage will be like this, but there will be no change in the battery because this is a fixed voltage. Now, if you can see, your diode is getting 2 voltages. This battery is making this diode forward bias, but this input is making your diode reverse bias. Why? Because this is P and this is negative, opposite sides. So what will be the final status of your diode? It will be forward bias or reverse bias. How we can know this? We have to know which one is big. For example, till the time your input voltage is less than 5, assume that this is the point where your voltage is 5, minus 5. Till the time your input is less than 5, battery is big. Mukabala input signal. Natija, your diode will be because effect of battery will be there, which will be forward bias. So if it will be forward bias, means your output will be same. Let us again solve this. It is minus plus, and we are going this way. Let us use KVL, and we start from this point. How will we write plus VI minus 5? This is forward bias plus VO. Why VO? We are talking about this loop, and in this loop, the voltage here is VO because these two are parallel, equal to 0. From this equation, we can calculate the value of VO because this is what we want. We want output voltage, right? So VO will be minus VI plus 5. Okay, or you can say it will be 5 minus VI. For example, if input is 1 in the negative half, your voltage will be 5 minus 1, 4. When input is 2, 5 minus 2, 3. When input is 4, 5 minus 4, 1. This is the way you will get your output. Now the last part is what will happen when your input is in negative half but more than 5, means minus 10, minus 15 or minus 12. This is a bit tricky, and let us talk about that. It is minus plus, and this is more than 5. VI is more than 5. Now in this case, if you see your diode, this input voltage is making it forward by reverse bias. If P is negative, means opposite, but this battery is fixed, so it will make it forward bias. Now you know very well that if there are 2 voltages, what will be the result? If they both are forward bias, if they both are reverse bias. But if one is forward and one is reverse, it depends on which voltage is big. And we have already told that input voltage is more than 5, means it is bigger than the battery. And this makes reverse bias. It means your diode is reverse bias. And you know how your diode behaves in case of reverse bias. It is like an open circuit, or resistance very high. Natija, your signal cannot go to the right side. So in the output, you get nothing or 0. And this is the way you will draw it in the output. I hope it is clear. It is a very important question for your exams, and it is a bit tricky. So make sure that you revise this again. I will upload this maybe in the YouTube or in the Blackboard, and you can download this, or you can read it, listen it again and again. And still, if you have any questions, you can ask me by writing comments or message or what. Any questions on this? Do you have any questions? Yeah, all of you, anybody is there? Nobody has any questions. All of you are Superman. You understand everything, right? Nobody's microphone is working. I want to listen from your side. Anybody is there? You try using your microphone. Yes, all of you. If you have any feedback, you want me to repeat or some specific point, I will be happy. But I want you to use your microphone and talk to me. Anybody else? Taha is in the home and he cannot talk. Anybody else? Anyway, I hope it is clear, but still if you have any questions, you can, I will keep in your Blackboard, there is a folder called recorded folder. I will keep it over there, or maybe in the YouTube, you can, I will share you the link. Please listen to that. And second thing is, I want to request you to add me in your WhatsApp group. Do you have WhatsApp group? I am messaging my number. Please add me in your group, because now we have to communicate with each other and it will be easy. I have messaged just now, so maybe you can add. It will be easy for me. Anyway, that is all about this. Now let's talk about next topic. Now again, it is parallel clipper. Okay, just to repeat, if you see the last example, you know what is a clipper. I just started with the definition. Clipper means cutting a part of a signal. Now this is a clipper. Why it is a clipper? See the input signal and see the output. You see a part of your input is cut. This is another example of clipper, means cutting a part of your input signal and keep the remaining whatever you want. So this is what a clipper does. Now let's come to the another topic of clipper, which is parallel clipper. And you know what is parallel clipper. In case of parallel clipper, your diode will be in parallel to the output. Fine, very simple. Maybe you can have batteries in the circuit or whatever, but how you will know into series or parallel? See where is diode. If it is parallel to the output, it is parallel clipper. If it is series to the input, then it will be series clipper. Hope it is clear. The same thing is mentioned here. Fine. Now again, in very brief, we will talk about this circuit. This is the circuit. These are the inputs, and this is what you are going to see in the output. Whether input is the figure on the top or figure on the bottom, this is the way your circuit is going to look. Fine. So let us talk about one by one, or they are all same. Your signal is again having two halves. Your signal is having two halves, right? Positive and negative. Let us start one by one. You know what is positive half? Positive means this is plus and this is minus. Can anybody tell me your diode will be forward bias or reverse bias by message? Very fast. In this case, right now we are talking about positive half, means your input is this one. My question is, in this half, your diode will be forward bias or reverse biased? Of course, your diode will be forward bias. You know why? Because you know the condition, when P side is getting positive voltage and N side is getting negative voltage, it means your diode is forward bias. Now it means in this circuit, for positive half, your diode will be forward bias, and if it is forward bias, means your diode is short. And you know what do you mean by short? Forward bias means short, and short means like a line with zero voltage, or you can say your voltage will be zero. Now you see there is a difference between this one and last example. In last example, your diode was here, so even if it was short, your output was different because your output was not at the same place. But in this circuit, your output is same as the voltage. And since right now voltage in the diode is 0, your output will be, of course, 0. You have to understand it very clearly, because if you will compare with series clipper, you will be confused. So be clear, okay, that in positive half, your diode is parallel, your diode is forward bias, means short, and your output is parallel to the diode, and your output voltage will be 0. Hope it is clear. Now, if you will talk about negative half, in case of negative half, the difference will be your input voltage will be opposite of what it was earlier. Now, any guess your diode will be forward bias or reverse bias? Anybody? It will, of course, be reverse bias. You know why? P side is getting negative voltage and N side is getting positive voltage. Because of this, your diode will be reverse bias. And if it is reverse bias, means big barrier, it is almost like open circuit. Now, you know, if it is like, oh, this is again a bit tricky, so be careful. This is minus, this is plus, this is VI. And if you talk about the signal on the top, it will be VBus. So I will write like this. That is during a positive half, voltage is how much? V. How you know? From the figure. Sorry, we are talking right now about negative half, right? We are talking about negative half. Negative half means this is minus, this is plus, and the value is how much? It is there in the figure. It is V. Your diode is reverse bias, so it is open circuit. Now, how much is the output? For output, again, we will put KVL in this loop. And you know, there is no current. So voltage here is how much? You know, voltage in a resistor is V equals to IR. I is 0, so voltage here is 0. Now, how much is the output? Now, since your diode is parallel to the output, voltage here is same. So let us write KVL in this loop. Let us start this point plus. So it will be plus V. And voltage here is 0 plus VO, that is V output, equal to 0. So V output equals to, we will take V on the right side, it will minus V. And you know this graph, how to draw the graph. V means on the upper half, and minus V means upper half, lower half, and minus V means this is what we are getting in the output. Hope it's clear. Any questions? This is how our diode behaves when they are forward bias and reverse bias, but be careful when you see your circuit. The way you get your output for series is different from parallel, because when your output is parallel to the output, if your diode is forward bias and short, your output is 0. Hope it is clear. If you have any questions, please go back and listen to this part of your video again. And still, if you have any questions, I'm here to answer you. You can ask me the questions. Now, these are the examples. It is there in your slides, in your book and all. You can go through them. And this for your practice. And in all these are the circuits. I hope you can see on the screen. These are the circuits. This is the input you are applying. And for different circuits, these are the outputs. In fact, Clipper is a very important question for your exam. You can get a circuit, maybe this one, or maybe this one, or maybe some circuit, and you will be having input signal, and you have to calculate, or you have to draw the output signal. So you have to understand how your diode behaves when it becomes forward bias, when it becomes reverse bias, and then you have to use KVL. And another thing is examples on the right side. In these examples, the input signal is again the same, and for different circuits, you are getting different outputs. So make sure that you practice very well, because this question, if you understand it, you will get good marks, but if you don't understand, it will be very tough to score. So be careful and study this, and if you have any questions, You can ask me anytime. Is it okay? Yes, all of you. Do you have any questions? Nobody has any questions. Like always, you understand everything. Fine. Okay. Now we will talk about clampers. Listen, we are having this class for understanding the clampers, and next class maybe you can message me your questions, and we will have a class of doubt or like in this example, if you find something tough, you can ask me to solve that, and maybe I will solve that. Fine. So don't worry, still we have time, but listen to the remaining part of the lecture today carefully. Now, as far as clamper is concerned, it is again a circuit having diodes and resistors. One additional thing we have got is capacitor. And to understand this circuit, you must be understanding capacitor very well. Fine. So what a clamper does, a clamper is used to clamp or shift or move your signal. Okay, I got a message from Muhammad Salim. We will review the lecture, and any questions we'll ask you. Thanks. This is what I'm looking for. If you can go through that, and if any question, you can ask me again. Yes. So as far as clamper is concerned, clamper is a circuit that is used to shift the level of your signal. For example, see this example. This is the graph of the input signal, and this is the graph of the output signal when your signal will go through the circuit. Okay, this is Vi and this is Vo. What it has done, you see your input signal, it's from V to minus V, but in the output your signal has shifted down, or you can say it is negative clamper because it is shifting your signal from 0L minus 2V. Hope it's clear that you can shift your clamp signal up or down vertically. If you have shifted completely on the upside, we can say it is positive clamper, and you have shifted your signal completely downside, it can be called as a negative clamper, which is clear from the figure. Hope it is okay. Fine. So this is what a clamper does, and what is and how you know your circuit is clipper or clamper. The basic difference is the capacitor. If you have got a capacitor in the circuit with diodes and resistors and all, it means it is a clamper. If not, then most probably it is a clipper circuit. Okay. So this is the definition. This is an example. And you want me to discuss this question? Let us discuss and let's try to find out whether the output is like this or no. So be alert, because this is a Taha is asking that VO or VO is 0. Yes, I will explain. Give me some time. I will explain this step by step. But this kind of questions, they have a fixed step or procedure. So be careful and listen to me carefully, because if you will try any other way, it will be very difficult, or maybe your answer will be wrong. So if you have got a question like this, and what will be the question? You have got an input signal. This is the input signal. You have got a circuit, and the question will be solve and draw the output circuit. Means what you have to do it, you have to solve and you have to draw this circuit, but you have to write the equations also. How you got this? Only a figure will not be enough. So let us talk about that. Fine. So now in this case, again, your diode is having your circuit or input signal has got two half, positive half and negative half. So we cannot solve everything at once. We have to do it step by step. So always remember that whenever you are having a capacitor, make sure that you are starting from the signal when your diode is forward bias. You know what is forward bias. This is your diode, and it is in parallel to the output. This is P and this is N. You know when you do forward bias, when it is positive and it is negative. So in this case, we will start with positive half. So when we will start with positive half, how much is the value of input signal? You can see from the graph it is V. Fine. So I write it is how much? V. And you know what? This capacitor, let us try to find out how much will be the output. Can anybody tell me? Your diode is forward bias or reverse bias? Anybody? Very fast, you can message me. Your diode P side is getting positive signal and N side is getting negative signal, negative part of your battery. It means your diode is forward bias. Same polarity means forward bias and opposite means reverse bias. So your diode is forward bias. If it is forward bias, means it is short, and your output is parallel. And you know, parallel have got the same voltages. If diode is short, short means 0 volt, right? If diode is short means 0, so your output is also 0. So you can see in the graph, your output is how much? It is 0 volt. I hope it is clear. Now you cannot jump to negative half immediately in case of clamper. Here is a trick. What you have to do? You have to calculate the voltage in the capacitor. This is a very important point. So how to calculate the voltage in the capacitor? We have to use KVL. You know, input voltage is V. And let us go this way. We don't know voltage in the capacitor. Let us assume it is VC. Why C? C is for what? Anybody can tell me? C is not for corona. What is this C for? C is for capacitor. Voltage in the capacitor. So let us calculate the voltage in the capacitor. Let us go to this loop. We'll start from this point, and it's not compulsory. You can start any point in this loop. So at first you got minus, so it is minus V, then plus, sorry. Again, I'm writing. Actually, I'm not used to with this writing this, so my handwriting may not be attractive, but I hope you are able to understand. It is minus V, voltage here. Why it is minus? Plus minus V. How we know it is V? Because of the input signal. Here it is 0. How it is 0? We have just concluded your diode is forward bias, so voltage is 0. In capacitor, we want to know. I have assumed it is VC. You know, assume. I guess it is VC. We have to calculate VC. So we started from this loop, from this point. So at first minus, so minus V plus VC. And what is the voltage in this diode? 0 plus 0. So it will be 0. All the Kirchhoff's voltage law is in a loop. The addition of all the voltage is 0. Now why I have written this equation? Because I want to know what is VC. So I keep VC here and keep V on the right side. So it will be in place of minus, it is plus V. What is the meaning of this? In the capacitor, the voltage is V. So I will clean the screen and I will write voltage here is how much? Plus V. Now we are talking about what will be the output for this signal, and we have completed positive half. We are talking about negative half. So when you go to negative half, immediately it will be minus plus V. But capacitor voltage will not change immediately, because you know capacitor has a property that charges and discharges, but it is very slow. So it will be V in the capacitor. Now let us talk about diode. Your diode will be forward bias or reverse bias. Any guess right now? Anybody is there who can tell me? Pause for a minute and think. It will of course reverse bias. How? Because you see this is P negative and N positive. It means your diode is reverse bias. By reverse bias, we mean that it will be like open circuit. Reverse bias. But what is our aim? Our aim is to calculate the VO or V out. So now we'll talk about this big loop, and we will use KVL in this big loop. And you know how to use KVL. Let us write this. Let's start from this point again, because this is the point we always use. So it is plus V. Again, in the capacitor voltage will be plus V, and then your output is plus VO. That's all. These are all voltages. If you add them, how much? It will be, of course, 0. So what is VO? VO will be, all this will be minus 3 minus 3 minus 2V. And you know, in the graph, how to represent minus. Minus means it is on the lower part. Maybe V is here, so 2 will be somewhere here. So this will be your output. For negative half, your output will be minus 2V. For positive half, your output, we have just discussed, it is minus, sorry, it is 0. So this is what a clamper does. So that is all for clipper and clamper today. I hope it's clear, and I have tried to explain you in the easiest way, but I am sure you still have so many doubts. So maybe one more lecture we will be having on this topic, and on that class we will discuss some examples of clippers and clampers, and especially clampers, because it is a bit tricky. So maybe you can go through the video, and again, for any doubts, you can again go back and see this, and if you have any questions, you can ask me. Is it okay?